Welcome on the day 14th of this online course, Physics with Scilab. In the last lecture, we have seen the program for the fitting of the polynomial curve of different degrees to the experimental data using the method of least squares. Today, we are going to see the programs for fitting of an exponential curve of the type y is equal to a into e to the power bx. Then fitting of the logarithmic curve of the type y is equal to a into x raised to b, and fitting of the curve of the type y is equal to a into b raised to x to the given experimental data. First, fitting of an exponential curve of the type y is equal to a into e to the power bx. Here, the values of a and b are to be determined such that the exponential function best fit our experimental data. To get the values of a and b, first we transform it into a linear equation by taking log on both sides. Here, capital Y is kept for log of y, capital A is kept for log of a, and capital B for b log e, which is b. So the equation becomes y is equal to a plus bx. So according to method of least square fitting, the normal equations can be written as summation y equal to a n plus b summation x. Here n is the total number of values for x, and second equation summation xy is equal to a into summation x plus b into summation x square. So from these two equations we can get the values of capital A and capital B according to these two equations. Now let's see the program. The command funcprot to avoid the message appeared when the function is redefined in the program. Then the function exofit is defined for getting the fitted values of y and the coefficients a and b. N is the size of the vector x, that is the total number of values of x. This if else statement is for performing the operations on all the values of x. Then for loop operations for the corresponding values of y. Then these are the terms that we are required for the normal equations. X sum is the sum of all values of x from 1 to n. Y sum is equal to sum of all values of y. X square sum is the sum of the squares of all values of x. XY sum is the sum of the product of the values of x and y. Then the b equal to n into xy sum minus x sum into y sum divided by n into x square sum minus x sum into x sum, and a is equal to x square sum into y sum minus x sum into xy sum divided by n into x square sum minus x sum into x sum. Then values of small a and small b are obtained using this equation, since capital A was log a, therefore a is equal to exponential of a, and capital B was b itself. Then to get the fitted values of y, the f of I is equal to a into exponential of b into x for the values of x from 1 to n and the end function. So this is the program to get the best fitted values for the exponential function. Now I will demonstrate one example. So the values of x are 1, 5, 7, 9 and 12, and the corresponding values for y are 10, 15, 12, 15 and 21. So we are going to fit this data to the exponential curve using this program. Then I will call the function exofit. Enter. So this gives the values for the coefficient a and b, and these are the best fitted values for y. These values you can check manually whether they are correct or not. Now we will plot simultaneously on the same graphics window the original values of y against x and then best fitted values of y against x. These marker shows the original data points, and this red curve shows the fitted exponential curve for the given data. So in this way we can get the best fitted exponential curve for the given experimental data using the program. So we take one more example to fit the experimental data to the exponential curve of the type y is equal to a into e to the power bx. The values of x from 1 to 4 with the increment of 1. The values of y, call the function exofit for getting the fitted data and the coefficient ab. So these are the values for the coefficients a and b, and this is the fitted points. Now plot the original data with the markers, and on the same graphics window we will plot the fitted data. The red curve, the curve is best fitted with the given experimental data. Now fitting of the logarithmic curve of the type y is equal to a into x raised to b. Again, it is converted into linear equation by taking log on both sides, where y is equal to log of y, capital A is equal to log of a, capital B is equal to b itself, and here the capital X is equal to log x. Equation becomes y is equal to a plus bx, and therefore the normal equations are written as summation y is equal to an plus b summation capital X. N is the total number of values for x. Then summation xy is equal to a summation x plus b summation x square, and the values of a and b are obtained from these equations are given by these last two expressions. Now let's see the program. So program is same as we have written earlier for fitting the exponential data. Only here I have defined the function log fit, and the new thing is that we have substituted capital X for log x, and rest of the things are kept similar. In this step I have used capital X instead of small x. Here also, in the expression of b and a, there is capital X instead of small x. Then a is equal to exponential of a and b is equal to b. Then for loop from 1 to n, values of x, the fitted values of y are given by a into x raised to b, and end function. Let's see one example. Save and execute. The values of x, the corresponding values of y. Now call the function logfit. Enter. So these are the values for coefficients a and b, and these are the best fitted values for the y. Now plot the given data, some markers. On the same graphics window, we will plot the fitted data with the curve. So this is the fitted curve for the given experimental data. So in this way, we can use this program to fit the logarithmic curve to the given data. Now fitting of the curve of the type y is equal to a into b to the power x. Again, it is converted into linear equations by taking log on both sides, so that we get the equation y is equal to a plus b into x. The normal equations are summation y equal to an plus b summation x. Summation xy is equal to a summation x plus b into summation x square, and n is total number of values for x, and the values obtained for a and b from above equations. Now let's see the program. This program is also similar to the earlier programs, only some necessary changes I have made. The change is only since the capital B was log B and capital E was log A, so therefore we obtain the values of coefficients small b and small a by taking the exponentials of capital B and capital A respectively. Then in the for loop, for the n values of x, the fitted values for y is equal to a into b to the power x. in function. Now let's take an example. So I will save and execute the program. The values of x, the corresponding values of y. Now I will call the function power fit to fit the given experimental data to the curve of the type y is equal to a into b to the power x. Enter. These are the values for the coefficients. These are the fitted values for y. Now I will plot the given data using this 2D function. On the same graphics window, I will plot the fitted values for y obtained from the program. This marker shows the original data points and the red curve shows the fitted curve obtained from the program.